Hey y'all, Royce from Hill Country CNC and Woodworking, and today I'm going to show you how to make a ladle, making a bowl off of Aspire or Vectric VCarve Pro. We're going to go through the whole process, and I'm going to show you how I was able to make this and end up winning a competition from Woodcraft. It was pretty cool. So hang with me. We're also going to jump into the Aspire update to 12 and some of the little changes that you'll see with the program. Don't forget to like and subscribe. Diving in, we're going to go ahead and create a new file. I have a huge chunk of wood for this one. It's 7 1/4 inches by 7 1/4 inches square and 2.152 thick, so it's a really big piece. We're going to do double-sided. We're going to surf. The 0 is going to be off of material service. My datum is always in the bottom left. It's just the way I roll, and I think it makes sense for CNC people. And then of course I'm going to change my modeling. We're going to go ahead and pick our dome, which is going to be the bowl of the cup. I don't know why I can't find it. Here it is, domes. It's already on it. And I'm doing a 90 degree because I want this to be like a 360 degree sphere cut in half. I don't want a slight angle. Then I'm going to go ahead and center it. Everything I do on this is centered because my XY is in the bottom left. So it's got to be precise. And I'm going to resize it, and the outside of my ladle is going to be 5 inches. So the inside, which is what we're working on now, has to be smaller. And I'm taking 3/16 off. So it's 5 minus 3/16 equals 4.8125. Now you can see that what we have is a dome, and that's not what we want. We want a bowl. So we have to go in and change this. So we'll go ahead and select it and head over to components. We'll see our dome dish. Open that up, double click it, change the name if you want. I think ladle bowl describes it better for me. And then I'm going to jump down to the shape height. I know that my material is 2.152, and I'm taking 3/16 off of that. So I'm going to do 2.152 minus 3/16 equals 1.9645. From there, we're going to move up and we're going to subtract from previous components. I normally hover over it so that you can see it, but on this one I just didn't. And there we have it. We have our ladle bowl, and in 3D view you can see that it's actually a bowl instead of a dome, and that looks perfect. When you look at that, you can imagine that it's just free floating in space. So what we need to do to give the computer an idea of what we're actually talking about is to create a vector boundary. So that gives the limitations for the toolpaths. And then we're also going to create a 0 plane by clicking Shift and obviously clicking it. We'll go over to components, and you'll see that that 0 plane is there now. And when we move over to 3D view, you'll see, boop, the black line is your vector boundary, and you can see that it now has a 0 plane. Flipping the material over, we're over on the back side now, and that circle that you see is the vector boundary for the front side. It's just there to let you know, hey, this is where your shape is on the front side. So now we're going to go over to clip art, get our domes and dishes, And I again am using the 90 degree, and we'll throw it on there. And of course, Royce likes to center everything. There we go. We'll go ahead and move and change the size. As I said before, the entire diameter will be 5 inches. So if you have link XY checked, you go ahead and put in 5 and you'll be good to go. Click apply, and there you go. Quick tip, I used a yellowish orange ruler on the top and side just to let me know which side I'm on, because it gets confusing when you're doing these. I'm adding a vector boundary, but don't do this right now, or you don't need to. You can always remove it. But I'm doing it so you can see the 2 vector boundaries and you can tell the difference between them. If we took that measuring tool, it would be 3/16 of an inch. So just keep that in mind when you're doing a round surface with a round surface and it's all dimensionally the same. It's going to be 3/16 anywhere on that bowl. That vector boundary will be removed because we have more stuff to put on here. But you'll notice now that it is switched to merge. Merge. And we need to go ahead and change this number. Like I said, for the 3/16, we're cutting all the way through this material, and it is 2.152 thick. So our inner bowl is 3/16 less than that. So our outer bowl will need to be the entire thing. So if you get what I'm doing with the round object, subtracting from the round object, you can probably just skip forward. But I'm just kind of trying to overemphasize the geometry of this. When you're doing a bowl, it's actually very simple to make something perfectly round. If you're doing a plate or something like that, not quite so much. So that 1.9645 is my original 2.152 minus 3/16, and that will be there for the whole. Every surface will be minus 3/16 of an inch. So I had done some of these bowls before, but I watched Mark Lindsay's video. Shout out to Mark Lindsay. And he taught me some stuff that I thought was really cool. So I'm going to go ahead and pass it on. The big one for me, I always assumed that I was getting my dimensions correct all the way across. But I never really had a way to figure that out, because you have your X, your Y, and your Z. And unless you're just like a super machine mathematician, you can't figure that out. But if you press Control, which is what Mark taught me, you'll get the thickness, and you'll be able to see over there on the right hand side, you'll be able to see the material depth. And that was a game changer for me. Moving on, we need a way to hold this dish down. If we remove the entire center of the dish, there's nothing for it to stick to, and there's no way to clamp it down, so we need to have some tabs. I think on VCarve and Aspire, the tabs are really easy. You just go over to your clip art, grab your circular 1/4 inch tab, and throw it on there. And really all you want to see is that it's touching. Hold it down there. Good. So you can see where it's touching, and you can see the kind of the curve there. And that's really all that matters. I have not had one of these fail in any form or fashion. Okay. So now we want to do a circular array. We'll just go down to the circular array tool. 4 sounds great. And then because we're not going off of the center datum, we're going off the bottom left datum, we have to know the dead center of this bowl. This, I guess, is a little harder about the way that I do it, but you don't have to change anything. So for mine, if you click on the bowl, it shows you the center is 3.625. All right, so you copy that and then go back to your rotation center and just paste it in for both the X and the Y. And now you have dead center. Click copy, and there you go. So if you recall 11 minutes ago, I'm making a ladle, not necessarily a bowl. So we're going to go over to our tabs again and grab this 3/4 inch rectangular tab and go ahead and drag it over. Boop. Hit 0 twice, and then position it kind of where you want it. I just wanted it sticking out just 1/8 of an inch from the bowl so you can see the curve. So I'm going to go ahead and center it horizontally. And then I'm going to show you what this looks like. And you'll see that, hey, it's there, but that doesn't quite look right. So we'll head over to components, and that's our rectangular 3/4 inch. It's merged, which is what we want. But the reason it looks funny is it's only 0.125. Well, that's nothing. We want it 1 1/4 inch. So I change the shape height, and now we go to 3D view, and you can see how that brought it up. If I zoom in here, you can see the curve where it's merging to the dome of that ladle. And so now that we have all our pieces there, we're going to go ahead and create that vector boundary for the toolpath to understand what is actually there. We're going to go ahead and move on to the next step in this design, which is adding the dowel holes. If you understand the concept of this, the dowels are going to be in your spoilboard and in your top side so that you can attach your material once it's flipped. So we just go over to draw circle and add a few circles. Make sure they're an irregular pattern, because if they're exactly aligned, then you can misalign your material. Now that our dowel holes are made, we're going to go ahead and select all 3 of them by holding shift and clicking on them. And then once we have all 3, we're going to right click on our mouse and copy to other side. And if you flip your board over, you'll see that they're on the opposite side, which, because we made them irregular, they're not in the same place. It's a mirror image. Okay, so now we're going to jump into our toolpaths. So select all 3 of the front side dowel holes and go to the drilling toolpath. Our start depth is going to be 0. Our cut depth is going to be 1/2 inch. And I use the 46102 upcut. You want upcut for drilling because it pulls the material out. The bad stuff is going out. With a down cut, it pushes it down. We're going to do a pass depth of 0.125. And then go ahead and click on Use Peck Drilling and retract above the height of the previous pass. I'm going a little less aggressive with my retract gap. I don't think it's that important. But what's going to happen here is your drill is going to go down, and then it's going to go up 0.05, then it's going to go down 1.25, then it's going to go up 0.05, and it's going to go down 1.25. And basically what it's doing is removing all that material just like a drill would do. So we'll go ahead and change the name. I follow a pretty standard theory, so I'll have what it is, what I'm using, which is an upcut, the bit number 46201, and the depth. Go ahead and hit calculate and hit the preview, and boom, there it is. There's your 3 holes. Nothing amazing to see here. Moving on, we're gonna go ahead and do the inside of the bowl. So we select the vector, and then we're gonna go to the 3D roughing. I'm gonna change my tool. My favorite bit is the 46202K, but it's not long enough for this operation. So I'm gonna find my 46502, I believe it is. Yep, there. And you'll see that one's got a 1.5 inch cutting shaft. Select that. We're going to do cut selected vectors, no boundary offset, machining allowance of 0.02, Z-level raster, or Z-level roughing strategy. It's just quicker. There's no need for a raster right now. No plunges, and then we're gonna rename it. Now in hindsight, I wish I had said 3D roughing top, but I didn't. So here's my 3D roughing down cut 46502K with it's a 2.152 depth, which is actually wrong. It's really 4.8125. I saved it wrong, but I knew what I was talking about there. And go ahead and do the preview. Hit play, and there you can see it machining everything out. Keep in mind, I'm making a perfect circle, so this thing really just cuts down forever. It's like 6 passes pretty much straight down, and then you'll see the graduation of the cut. Go ahead and click close, and we'll see the file there. Everything's good. Stay on that selected vector, go to 3D finishing, and we're going to change out this ball nose. I don't know why it always goes to that same bit on the finishing. It's annoying to me. I wish it would just select my bit that I always use, which is the 46376K right there. And then I'm going to change the step over just a tad. I'm going to bump it up to 8%, which in theory could cause me to do more sanding, but I'm planning to do a ton of sanding on this thing anyways because I want it to have almost a mirror finish. So speeding it up is just a benefit. So apply and select that. Delete the ball nose. And then we're going to go use the selected vectors, no boundary offset. And here's where we're going to go to the raster. And if you watched the Mark Lindsay video, that 40 degree, I took that from him and it's a great idea. Normally when you mount your wood, you mount the wood grain vertically or horizontally. Going at that 40 degrees means that you're cutting across the grain, which is kind of an interesting concept in woodworking, but it makes a really nice smooth finish. So I'm naming it. I got my 3D finish. Again, I wish I had said top. Upcut 46376K, and then the depth. So we'll go ahead and do our preview, and you'll see that raster at 40 degrees takes it from the side there. That's what that does. And that looks great. Nice smooth bowl. Close, you'll see your file again, and there it is. Go ahead and flip it over, and we're going to do the same thing. We're going to drill our holes. So shift and select them. Go over to the drilling toolpath, and it's all the same. No changes. And we drill it. So it's upcut 46201. We're going to go ahead and put Spoilboard on here because my naming conventions are all about letting me know which file I'm supposed to be using. So Spoilboard reminds me that I'm drilling this into the Spoilboard. Go ahead and run the preview. Three little holes. Pretty simple. Again, on the reverse side, we're going to go ahead and select the vector and do the 3D roughing. My bit stays the same. Selected vectors, boundary offset. So this is a change. I set my boundary offset to 0.3, basically because my bit is 0.25, and I want to go a little bit beyond that. The rest of it is the same, the machining allowance, the Z level, roughing strategy, no ramp, and then I did the name the same way. I finally remembered to put which side I was working on, which was the bottom on this one, and the depth. So calculate, and there you go. There's the pattern. Sped it up a little bit more, and there you go. And you can see the tabs and the part where the ladle will attach to the handle. Go back, and same vector is selected. We will do the finishing, and there's all my saved information. Selected vector, boundary offset, shifting it to 3. We're going to do that raster again, 40 degrees, works really good. Then go ahead and change the name. So upcut 46376K. Bottom. I could type slower. This is really bad. I'm sorry about this part. Click calculate, and here we go. And hit play. And here you'll see that checkered or dotted area. That's actually cutting through the material. It's showing you that in theory, you have gone to the zero plane. You haven't gone through it. What I have experienced in doing items like this is that actually cuts all the way through. I don't have to make another cut or anything. I'm precise enough with my numbers, and my machine is precise enough that is zero, which means there is no material in between my Spoilboard and air. And that's it for the Toolpaths. You've basically made your bowl for this ladle, and now it's just on to saving. So go ahead and select your upper or top. I do visible toolpaths to multiple files. I do not group. I use my GRBL post processor, stick it in my file, and then I'm going to go ahead and remove all this information here and just put something simple like ladle, and you'll see why as soon as I save it. And then we'll switch over to the back side, select those three toolpaths, go over to save, same thing, visible toolpaths using GRBL, and save toolpaths. And you'll see here where that ladle just did the front portion instead of copying all of that. If you didn't do that, it would be drill UC 46201, blah, 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 blah. So just having that ladle there makes it much simpler. So this is just me probing for zero. And there's my big chunk of walnut. Basically, I should record the screen part of this one day, but you're gonna attach everything and then put in the parameter of your bit, and it does the rest. It's real simple, but it's basically just making little magnetic connections there to see exactly where the bit is. If you're wondering about those scratches right there, that's from my surfacing bit. When I was trying out a new surfacing bit, I didn't realize that the width of it was too wide, and well, it got my probe. So this is the top side dowel drilling, and it's just real simple. You can kind of hear how it retracts. It's hard to see. You can see it stop. See it like bump, bump, bump. And my camera was too close, so that didn't help. So here we are, went ahead and started the cut of the roughing, and as you can see, it's just roughing it out. This is sped up 350%, but I feel like some people are going to want to watch the entire thing. So the entire cut is in this video. If you don't want to watch that, I put chapters down below, and you can just skip ahead to the next spot. It's hard to to help everybody, because some people are just going to want the big information and some people want to see every single step. So I'm giving y'all both. Again, because this is a really long video, all of these videos where you're watching me cutting this bowl, they took forever. I'm a very conservative cutter. I would rather my project take 4 hours than break a bit or something like that. So they're all very long. But what I wanted to mention was, since we're here and we have time, you may be wondering why I'm not using any dust collection. It's really just so you can see on the video what's going on. You can see that little black tube on top, that's actually a Kraken 3D printing dust collector, and I just don't have the bottom part of it attached so you can see. The walnut was a piece of scrap that I had laying around. I went ahead and kind of cut it into a rough size and then jointed it and planed it. Joining it was pointless, but I digress. So I glued it up with Titebond 3 and it worked perfectly. The attaching to the surface bed is, as you can kind of see it, painter's tape with Starbond CA glue. I have found that as long as your surface board is super flat, you can use this method and your material's not going to go anywhere. So while we're at it, I'd like to remind you, hey, please like and subscribe. I am trying to build this channel as a form of income for me and my family, but also because I would like to open a woodworking nonprofit for veterans and first responders. I think I have the skills and the teaching style to do this. So, and I also have the connections here near San Antonio to be able to make this happen. So if you help me with this, I might be able to make that nonprofit. A little editing magic, and that wraps up the 3D roughing for the inside of the bowl. We're moving on to getting our Z height for the finishing. Wanted to mention on this view, if you see the rings at the bottom, that is an error, and the best thing that I can account for with that is that my roughing bit had to have slipped just a little bit, and if you look, the deeper it goes, the more progressive that dip is. So there is a very decent possibility that that bit just slipped in the collet just a little bit and caused that error. I ended up going with it. It's in my ladle. It looks great. I made it part of the design. Next is drilling the holes in the spoilboard for the dowels, and Yes, I almost let my wood get me in trouble again. On a different note though. So we're milling the roughing on the top side or the outer side. I guess actually the whole time we've been doing this, it's the bottom side. And this cut, if you're wondering, it takes forever. I have cut a lot of it so you won't have to sit through everything. One thing I wanted to point out real quick for those new to CNC, if you see those chunks of chip, those chunks are actually a really good indicator that your chip load is optimized. This in turn reduces heat friction and will cause your bit to last longer. It's the same concept with circular saw blades and stuff that nobody thinks about, but is super important to learn about if you ever want to become professional in any of these competencies. As you will undoubtedly notice, my chunk of walnut got smaller. So, yeah, that last, the roughing just made me nervous that I was going to end up hitting the collet with the bit. So I went ahead before starting the finishing and just cut off a layer of the walnut. It never did hit on the roughing, but it was really close, and this bit is not as long as the roughing one was. Big reveal, everything turned out really well. Like I said, when we were designing it, it cuts all the way through. It's pretty firm on there, but you'll see right here, like I just nudge it the right way and boop, it just popped right off. That one tab broke, which is fine. Yeah, I went ahead and cleaned it up a little bit for this, and you'll see the thickness. You'll see how smooth that finishing pass gets. That looks like it has ridges, but it really doesn't. It's ultra smooth. A little bit of sanding, and I think that this will look fabulous. So I'm not going to teach you how to use AutoCAD. But for the second part of making this ladle, I went ahead and used AutoCAD because for me, it's an easy way to lay out a two-dimensional piece. You can do this on VCarve or Aspire, but to me, I find it much harder to get exactly what you want with those programs. Even harder with Fusion 360. So here it is, AutoCAD from Autodesk. And basically what I did was I knew roughly the length of this piece, and then I knew that this piece was going to be, you know, well, so I come over here, make it snap. I knew this was going to be that, and then I was like, oh, I know what this ledge here is. So I did that, and so that gave me the initial pieces. Then I drew some guidelines because I knew that it was going to be 14 something inches tall. So I knew that I could stay in those parameters. So I just started playing with things. I think I drew the circle next. And if you look at this design, there's a lot of circles, which makes it kind of easier in some ways. I got unsnap. Y'all just saw me unsnap, right? Unsnap. So you just start playing around with angles. See, that angle is going here. And obviously that one doesn't work, so escape. We'll go here. And then you can kind of start to see where this builds. And that snap to the center, which that happens. Always ticks me off, but like I said, I'm not doing a tutorial on bro. I'm bad at some of this. And there's a repeat button. Just for the life of me, I can't remember it right now. So, you know, you just start building it out, and you come up here, you need a bitty circle. I'm just not doing well with this today, but you get the idea. I basically just patched all this together. The mouse is not concerning itself, and I guess that's a problem. I'm snapping to the center, which is not checked off. Doesn't matter. So I'll go over, like if you look over here, and, you know, basically, I'm just building this thing out. I did a whole lot with and I totally messed this one up. But you can see where it's easy to do certain things. It's the same one over here. Move. Not getting it right, but so it doesn't even matter. I just wanted to show you roughly what I did. Is it's simple, you know, you go through, you create all this stuff. Oh, those two aren't touching. That sucks. You just go through and clean everything up, and the end state is that you'll end up with this 2D design that is, I mean, it's functional and mathematically proportionally correct. That's the kicker, is this line here, this part here, and this part here have to be perfect to fit on that bowl. So I imported it into Aspire as a DWG. It's single-sided. There are my measurements of my material. My datum's in the lower left, and walnut. Everything is pretty much the same. So there you go. Go ahead and click on it. So we're doing just a 2D profile toolpath, and we're cutting all the way through, so it's 1.08 inches. I'm using my favorite Amana Tools 46202K. I use that thing for everything. As stock, it wants me to do 22 passes. I'm very conservative because, again, I don't like vibration and I don't like things breaking. So I bump it up to 26. Oh, and see that it changed because it wants to do 22. So we bump it up to 26, and there you go. We're cutting on the outside of the line. We're going to do tabs. The length 0.02 and the thickness 0.125 inches. And I'll show you, you know, I didn't accept the pattern of the tabs that they put on there. I moved them around. I did a ramp with a zigzag and a very short ramp. I don't like the long ramps. And then, of course, my name is labeled the same. I put the tabs in places where I thought would be out of the way, but would provide security for the handle. So here we are in preview mode. I'm going to bump it down just a touch so you can see it. Cuts all the way through. Takes a little while. I think 13 minutes. And that's it. It's real simple. I sanded off the tabs once this was done, and well, I'll show you that. We go ahead and save. I did it the same. Visible toolpaths to multiple files. Group where possible is not checked. My CNC, and then GRBL. Save toolpaths, and that's my file. And then I'm naming this handle because, remember, it's actually going to say handle dash ladle cut blah 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 blah. Just probing the X, Y, and Z for the ladle handle part. For those wondering, I use a Onefinity CNC. They're out of Canada. Great group. Excellent service. Any problem you have, they'll fix it in days. You know, shipping all the way from Canada, it'll get to you quick. And then I mentioned it in some of my other videos. I almost only use Amana Tools bits. I've just learned that I love them. They're great. They last. They stay super sharp. I mean, they're just really good bits. They do cost a little bit more, but you know, you get what you pay for. It's the same argument with a Festool miter saw. You know, you're getting a better saw, so I think it's worth it. There's nothing really magic about cutting out the handle, but one thing you may be wondering is the cornered bevel right here. Okay, so I actually had to chisel that out to get a 90 degree so it would fit on the ladle perfectly. Probably my last recommendation for this video is just going to be this sander. If you don't have an oscillating spindle sander, wow, these things are great. I love mine. So this is a rigid R4840, and I want to mention it just because if you go to one of the big box stores right now, they have this one. Most of the stores have this one, but they also have another version, the newer version, which is $90 more, and it does exactly the same thing. I cannot figure out a difference between this version and the new version, which is a lot more plastic.
Last, I wanted to do a shout out to Woodcraft San Antonio. Their monthly competitions always spur me to think in a different direction, and every time I do one of these, I learn something new. So thank you so much, Woodcraft.